data is about how the movement of market affects each of all green franchise. As we all know, dependent variables is the effect while independent variables is the cause. Examples of dependent variables is number of competing stores in district, size of sales district, and also the number of square footage. Examples of independent variables is annual net sales, inventory, and amount spent on advertising.
Next, I would like to present simple linear regression analysis on dataset number 1. 3.1 is scatter plot. The graph that shows here are the variable result extracted from SPSS. As you can see, there is 5 graph scatter plot of x1, x2, x3, x4, and x5. Next, 3.2 correlation coefficient. From the summary data we extract from SPSS, we found that all the independent variables do have strong relationship and strong correlation with our dependent variable. But only one model we have to choose, which is X4, because it has the highest R value, which is 0.954, and that we consider as the strongest linear relationship with Y. Next is 3.3 general form of SLR equation. In this general equation, we use y equal beta null plus beta 1x plus random error component.
Next, we go to the 3.4, which is testing the regression slope P1. To support the significance of the observation, t-tests were used where hash null beta 1 equals to 0 and hash alternative beta 1 unequals to 0. The regression slope, which is the p-value is less than 0.05. In this situation, we reject hash null because the p-value is less than 0.05, because there is a significant relationship between variable x and variable y. Next, we move to the 3.5, which is the coefficient of determination. If r is 0.90, then r2 is 0.91. It means that 91% of the variation in the dependent variable is accounted for by the variation in the dependent variable x. The rest of the variation, 0.91 and 9.1%, is unexplained and called the coefficient of non-determination. The formula for the coefficient of determination is 1 minus R2.
Hi, my name is Nur Aida Ilyani binti Zulkifli. My metric number 221220710. 3.6 Overfitting. A model tries to adapt itself to much data. The item represent a different class, include 2 lines, that is machine learning model, made to distinguish between different classes. 3.7 Multicolority. 2 or more of the predictions strongly with each other. The effect of individual variable cannot be clearly separated. Multicolority occurs when the variable themselves related. 3.8 Model comparison. Show that the histogram graph, normal p-plot, and scatter plot.
3.8 model comparison. These are the 3 pictures of model comparison. Next is 3.9, the best fitted model, which is normal p-plot of regression, standardized, residual, and second is scatter plot. 3.10 is point prediction and best model. For normal p-plot, the data points are around the 45-degree line, and this indicates that the data is not abnormally distributed. Meanwhile, for scatter plot, that indicate the data points are in the range 1.5 to negative 1.5. This shows that the data is not abnormally distributed and there is an outlier problem. And lastly, 3.11 hypothesis testing. So this is the multiple regression equation that is shown below.
Conclusion: the independent and dependent variables have strong relationships. The model we choose is the size of sales district because it has the highest R value that we'll consider as the strongest linear relationship with annual net sales. There are several advantages of MLR, which is simple implementation, performance in linear separable of datasets, and also overfitting can be reduced by regularization. That's all. Thank you.